Okay, so question number 18. All right, at this point, if you can jump in if you want to. Okay, so does the weight of a car matter in determining how fast the car can negotiate a curve without going into a skid? The answer to that question is no, right?
No.
Weight is not going to matter. So the question is why not? Weight is not going to matter. Question is why not? All right, the reason is because the only reason why the vehicle is able to negotiate a curve was because of the static friction force, right? All right, so I'm just going to give you guys a short explanation for it. All right, so the only thing that really matters is the stuff that prevents you from going in a straight line at a constant speed is the static frictional force. Okay, so when you maximize the static frictional force, the vehicle is going to go into a skid, usually. That's what it means. All right, so this is the maximum speed at which you can negotiate it. And the static frictional force is sensitive to your apparent weight, which is going to be sensitive to your actual weight. Okay, so what that means is the more massive the vehicle is, or more massive the vehicle is, the heavier it is, the larger the apparent weight is, the larger the static frictional force is. So, which means that the amount of static frictional force that the vehicle is going to experience is going to be proportional to its weight. So, which means that the mass doesn't matter. Heavier the vehicle is, the larger the static frictional force is. So, the maximum speed at which they are going to be able to negotiate the curve is not going to depend on the mass. That's what it means. All right, question number 19. I think this is a Ferris wheel. All right, so let's take a look at this. So the Ferris wheel is doing this, just going up and down in this fashion. And so you're inside a cart when it's on top, just like that. And also let's imagine that this thing is moving sideways. Okay, so it's moving so fast that while you're sitting there, you're feeling weightless. Okay, so at the highest point, you're standing on a scale, and the scale is going to read a 0. It's going to give you a 0 reading. That's what it means. All right, so the scale is giving you a 0 reading as this thing is going around and around, and it's moving so fast that the end that you get from the scale, okay, notice that this is your center of mass. You're sitting there, so you got weight, and obviously you're standing on a scale, so this is the scale reading, and the scale reading is going to be 0, if that's the case. So if that's the case, the question is, all right, so the question is, what is the centripetal force acting on this person? All right, so the person's weight, the actual weight is going to be 500 pounds. So we got 500 pounds for the person, right? Okay, it's not 500 pounds, it's 500 newtons. I goofed that up. All right, so 500 pounds is a little bit too heavy. So the person's weight is 500 newtons. All right, so the person is feeling weightless. So what is the centripetal force acting on the person in this case? What do you guys have? What's the centripetal force acting on the person? Centripetal force is inner force, which is along the radial direction, right? Along this direction. So what is the centripetal force acting on this person in this direction when n is 0? All right, so the centripetal force acting on this person when n is 0 is going to be, what do you guys have? Nothing. All right, so what is the centripetal force acting on the person when the person is feeling weightless? All right, so when the person is feeling weightless, what is the centripetal force acting on the person? Okay, guys, I'm going to give you 10 points. It's okay. Lucia says it's gravity. Absolutely, give yourself 10 points. Centripetal force acting on the person is this, guys. It's 500 newtons. Okay, normally NW would be net there. Okay, hold on. Net centripetal force would be W is towards the center, N is away from the center. This is 0, so which means that the centripetal force is the same as gravity, same as the weight of this person. So it's going to be the same as 500 newtons. It's the same as 500 newtons. That's it. All right, next one. What happens to the tension in a pendulum move at the bottom of the arc? Does it increase, decrease, or does it stay the same? Okay, so you know the answer to that question. So you got a pendulum move. All right, so here's the cable, and it's going down. All right, so here's your cable. Here's the weight. And this one is the tension. And this thing is moving sideways. All right, so what happens to the tension? So tension depends on the weight, plus the additional tension is created by the motion itself, right? So this is what we got. So what that means is the faster this thing moves, faster the motion is, larger the tension is going to be. All right, so that comes out of math. So obviously that's not what I'm looking for. So I'm going to want an explanation for it. So obviously the tension is going to go up because of the speed. So the question is why. Okay, guys, as the speed goes up, the tension is going to go up.